Some basics from yesterday. Yes?
What is SPE?
Skills practice. So you'll see me use that all the time. And then to add to that, I had to print worksheets for you guys in the beginning because the skills practice weren't here. So now that the skills practice are here, most of your assignments, not all, but most of your assignments will come from the skills practice. I like the skills practice because there's also examples in there for you. And then I make my own study guide, I make my own tests, all that stuff is a Mrs. Stewart thing. Okay, so from yesterday's work, let's talk. If on your test I asked you to graph x to the 20, x to a big power, so in this case the power's even, could you describe to me in words how I would make that graph, like the shape and then something to make it look different than the parent or whatever? So tell me in words, not with hands. Yes. What shape is it?
Oh, it'd be like a U.
Okay, so it's like a U shape.
You have points at 0, 0, 1, 1, negative 1, 1.
Okay, so it would look like a U parabola, has points at 0, 0, 1, 1, negative 1, 1, which would make it concave up. But what would make it different from x to the 2? So far, all those characteristics. Say it again.
It'd be close to the x-axis.
Good. What would be close to the x-axis?
The beginning line. Before it hits, beginning of the parabola, before it hits negative 1, 1.
Good. So between negative 1 and 1, it's riding really close to the x-axis. So it almost looks like a horizontal segment right here in between the negative 1 and 1. So it makes it flatter. So if you make a standard looking parabola, that's not the x to the 20. Make sure you make it that little bit flatter as you get those bigger powers. Okay? Next thought was end behavior. Did anybody have trouble with anything with end behavior at this point? It's all year long. So if you get it now, you're going to love all those questions all year because it's the same thing. Okay, then we had to talk about even, odd, and neither functions. So you learned from a graph to be an even function, it had to be symmetric about the even. Was it symmetric about? The y-axis. Good. To be odd, it had to be symmetric about the origin, which also meant it had to go through the origin. Okay? But it doesn't mean that's all it did. So A, I check to make sure it did. Then I make sure that there's the symmetry. Algebraically. What is the math you need to do algebraically to prove if something is even? Go ahead. Good. So first you go into your problem and you convert all your x's to negative x's. You take them to the respective power and do the math. And all your signs to be even must be the same. Good. When I start, I look at the given equation. If the biggest degree there, the biggest power there is even, it doesn't matter what anything else is. The biggest power there is even, then it's an even degree, then that means my choice would be even or neither. If the biggest power there, like on number 16, was odd, then my choice is an odd function or neither. So now let's talk about odd. You go in and you replace all your x's with negative x, and then you do your math, and then after you do that, what has to happen? All the signs need to be what? Opposite. But when you had one like 16, did you know it was neither without any work? I know it was neither without any work. Last class did. What do you see? The constant. So if, let me finish, I'll take your question. I saw your hand. If it is an odd power to start, the biggest power there is odd, so the 3 is there on number 16, and then there is a plain old constant. Well, in order to prove odd function, every sign has to change. Can the constant sign ever change? No, there's no x to make it change. How can you change that? So here's the proof with the algebra. I replace the x with the negative x. There's nothing to replace with the 6 because there's no variable. So when I did that, negative cubed is a negative. So there's your negative 4. Good, that sign changed. But did the sign change with the negative 6? No, it can't change. There's nothing there to change it. So I knew right away that it had to be neither. Okay? So I could tell by looking at the 3 and seeing a constant that it would be neither. That only works with the odd. So 1, 2, 3. I did, but this is even. Remember what I just said, it makes a difference even or odd. For an even function, you want all your signs to stay the same. Well, the constant sign never changes. So that's why it didn't change. The odd, see how this is a power of 3. To be odd function, every sign has to change. Can the constant sign change? That's why it goes with neither. That's why it's specifically with odd. Not a trick with even. 2.
So the odd ones, every single time it's a constant, it'll be neither.
Correct. Wait, I couldn't hear over that. Now, if you see it, I want you to be able to see it. Like, I even look at it. In today's lesson, I'm going to take a graph like this. We're going to talk about the movement. I would love you to be able to visualize it without making a graph. Be able to picture it in your head, picture the actions, and then be able to tell me if that new graph is going to be symmetric about the origin. So if I could picture it, then I already know the answer. So you guys will be at different levels, but I see number 16 as, I'll get you next, as a cube being stretched by 4, a vertical stretch of 4, and shifting down 6 units. So today we're going to talk about that, and you'll see if it holds on to its odd function question.
For number 14, if you're changing all the x's to the negatives, then how come right before it says the answer, why are those all the same as they were before?
Okay, so let's see what happens. So do you see how I changed everything? So now you have to take it to its powers. So what is a negative to an even power? Positive. So that became positive. So you have to do the math. So negative to an even power is positive, times the negative made it negative. Anybody else? Clarifications? Okay. So make sure you look that over. 3-1, 3-2 is what's on your weekly homework questions tomorrow. It should be a quick, easy grade for you if you've been doing everything with me. There's nothing tricky on there, so I'm hoping to see lots of good grades. Okay, today we are working with transformations of the polynomial functions. We are going to get into quartic functions. Anybody know what a quartic is? 4th power, 4th degree. What about the word quintic? Have you ever had that or no? 5, good. So we'll be looking at these different degrees so that you can see all the similarities they have, and that once we have learned all this lovely information with the A, B, C, D, it is the same all year. Okay, so looking up here at the same equation we had in the last chapter. Look up here. Eyes this way. I know you can't see from the side of your head. Okay, tell me which variables, A, B, C, D, goes with the X. If I'm going to split things up and tell the ordered pair what goes with what, which of those variables, A, B, C, D, goes with X? There's 2 of them. B and C. B and C. So first of all, look close in. What's the closest to the X? B and C. Both of them, B and C. So now let's talk action. What does the B always do? It is a horizontal stretch and compress. Oh, horizontal. How does X's always go? Right, left? Okay, and then C, what does a C value do to your problem? Moves it right, left. Isn't that all horizontal action? That's why they go together. Okay, now let's think about the Y. Well, by default, it must be A and D. But let's think about what you do. If you were graphing an ordered pair, what do you do with the Y part of the ordered pair? Go up or down. What does the A value do? Stretch and compress vertically. And what does D do? Moves it up and down. So their actions go with their specific variables. So yes, you can memorize it, or B, you can just understand what goes with what, but it might be a good idea to write this down or take a picture so that it's upstairs, so you know what goes with what. There's a question coming up in the homework, and they gave you an example. I don't remember which one it was, but I know that the model had a 0.5 in the problem, and one of the people came up and said, how'd they get the answer 2 there? They used the 1 over b. What is 1 divided by half? 2. So they forgot to do the 1 over b part, and that's what confused them. Anybody still writing this down? Lovely. Here we go. Okay, so what I want to talk about with you right now is we're going to do it with what it preserves, and then I'll do it with formal equations in a sec. I need to know, given x cubed right here, that's the parent, if I do a vertical dilation, remember dilation is the big word for stretch and compress. If I do a vertical dilation, would it still be an odd function? So that's the question on the floor. Yes, it is, okay? Now, what if I do a horizontal stretch or compress? Would it still be an odd function? Symmetric about the origin? Yes, okay? So I wrote that to you so far. Now, what if I take this swiggle and I move it to the right? Would it still be an odd function? No, because then it wouldn't be symmetric about the origin. What if I took this swiggle, this cube, and I moved it up or down? Would it still be odd? No. So what I did right here for you on the table is I let you know what preserves it being an odd function. You can stretch and compress vertically and horizontally, but as soon as you move it right, left, up, and down, it's no longer going to be an odd function. Question?
So all the dilations are fine.
Yes, you got it. Uh-huh. And note, guys, also as you do your homework, I don't ever give you like the vocab part or anything like that, but a lot of my notes talk about the information that they have in there, just to make sure you understand what you're working on. Oh, in the back, especially if you're not used to the back, just tell me to move it up, and I can do that. Was JB playing? Oh, both. Guys, remember tomorrow is Spirit Day. If you don't get announcements in your second hour, that means wear your East Lake garb. And then lunchtime, did you hear what there is? Pep assembly in the gym, first come, first serve. Once they hit as many people as they're allowed to have in the gym, they lock the doors. So pep assembly, lunchtime in the gym. I don't know what's going to happen at this year's one. They used to have activities and okay, anybody still using this as I have announcements in between? Okay, next. Shh. Look what I did right up here. Shh. Look at my visual. My graph is the cube. So that's the graph C of x, which is x cubed. It's the parent. I haven't done anything to it. I haven't moved it yet, like I will be doing shortly. If I insert a 2 out in front, is this an A or a B? An A. Isn't this saying just take whatever your y value was from the ordered pair and double it? So it's going to stretch it because you're going up quicker because you're doing twice as much for the y value. And would that still be an odd function? What do you think? Yeah. What if I have the half out in front? Tell me in words what that's going to do to my graph. Squish it, compress it. In what direction? Vertical. Good. Okay? So that means whatever my y values would be, it would half it. You don't have to make tables if you're graphing these. You can just think it through. But think about, 0, 0. 1 is usually at 1. 1, 1 is a standard point on a cube, but it says double it. So you would put 2. 2 is a standard point on the graph with 2 comma 2 cubed is 8. But this says double the 8, so it would take you up to 16. That's the stretch. Every value is twice as big. Every y value is twice as big as it was before. How about if I write this for you? That's what it's saying to do. So if you make the table, so the only action is happening to the y. So I knew what the y was before, and I cubed it, or you can simply plug into a good old-fashioned table, -2 through +2, and it will give you your values to plot and make. Okay, next thought. What's happening here? I gave you the parent. I put numbers inside the parentheses. So show me with your hands what's happening. Good. Horizontal, stretch and compress. And then would that still be odd? Yes, definitely an odd function. Question. Can you stretch that into being, it would change. This is a cube, so it couldn't turn into a straight line. No, no. So it could stretch, and you might not be able to see all the curvature and the change, but a straight line, a vertical line, every single time your x value would be the same thing. That won't happen as soon as you plug in. Think about it. What is 2 cubed? 8. What is 2 to the 1? So see how they had different values? So that you won't ever see an actual straight line. It could be really skinny, but it still has that swiggle. Okay, what's this one doing? Moving it to the, talk to me, left and the right. So is it still an odd function now? No, good. What is this one doing? Moving it up and down. Is it still an odd function? No, good. So I wanted to show you multiple ways, whether it's in a chart form, whether I give you equations where you have to plug in. I tell you what the parent is, like the x cubed, and then I tell you what to do to it. Algebraically, you have to picture it and see if it still would be odd. So it's you totally understanding it. As soon as you do, it will make it so much easier for you. Questions so far? Anybody? Okay. Now, this is related to the parabola. This is an x to the 4. It is that U-shape, parabola shape, concave up, but it is wider, close to the x-axis between -1 and 1. The bigger the exponent, the more time it is running close to the x-axis between -1 and 1. I know I keep saying it over and over because I want you just to think it, to go like, how did I know that? Because Mrs. Stewart said it 20 billion times. That's what I want you to it to be upstairs. Now, let's talk about this nice even function and talk about what is preserved. Could I take this even function and stretch it? And it still be even? Yes. Can I compress it and it still be even? Yes. So that's vertical. What about horizontal? Yeah, I could. Horizontally as well. It just makes it wider, thinner. So far, yes and yes. Okay, could I take that graph and move it to the right and it still be symmetric about the y-axis? No. So I can't move it. I can't translate it right or left. So horizontal shift is no. Could I move that parabola up or down the y-axis, though? Yes. So that would be okay. That's what differs it from the cube. Okay? Because the y-axis gives you more wiggle room right there. I can just move it. It's not just one point. Question? Anybody? Everybody understand? This is from page 200 and it looks like a 54. And they're like your number 20 and 22 on your skills practice. Okay, check this out. Let's keep it simple. You are going to have a choice. When you go to fill it in, these charts are actually in the skills practice built for you. You can use the formal chart, or you can make an XY chart. It doesn't matter to me. Back in your days when you were graphing in Algebra 1, some teachers might have made you make an XY chart like this when you were graphing your line, and this might have said 3x plus 7. So you had to show them the work inside the middle part before you put your y value. That's kind of what they're having you do with our shape right here. If you want to show the work as you go, that's fine. If you don't, that's fine also. Okay? Now, I need to use the key they give us. So watch with me, please, so you get it, because it's not hard at all. It's just a substitution. They're telling me that my new equation is a of x equals h of x. So I go up to the top, circled in blue. What does it say h of x is? X cubed. So I'm going to write that up on top. And in here, since it's going to be my final answer, it says a of x equals h of x, so x cubed, plus, then it wants me to go twice g of x. What's the value of g of x? X squared is circled in red, and the equation says I want to write twice then x squared. Look at my substitution, see if you have a question. Look what I put in green from the key, from the equation, see if you have a question for me. Okay, so if I say write an equation, I did. That's the equation. That's the new equation. So if you wanted to make a simple XY chart, you would be plugging in numbers like -2, -1, 0, 1, and 2 from your x part into that equation to get your y value. And I have the graph done on another plane for you. Here's doing it step by step. So watch with me, please, so you can see the thought process. They did the -2 for you. If you take -2 and cube it, like it says, you get -8. If you take -2 and square it, you get 4. Now the rule, the equation says, take the cube value, the -8, plus twice the square value, 2 times the 4, do the math, it gives me my end result. Let's do the next one. What is -1 cubed, please? Just yell it out. -1? What is -1 squared? 1. Okay, so this says -1 plus twice 1, which would be 1. What's going to happen with 0? 0? Okay, now what happens with 1? 1 cubed is 1. 1 squared is 1. What is 1 plus twice 1? 3. Good. So like when you're building a table, that's what you do in your head. This one just has you writing out everything along the way, whatever you like better. 2 cubed I know is 8. 2 squared I know is 4. The rule says take the 8 plus twice the 4, which would give me 16. Here are my x's of my ordered pair. Here would be my y's on my ordered pair. I would plot those points to create a new graph. Question? Okay, so if you didn't want to put the in-between stuff and you just wanted to make a good old-fashioned XY chart, you would have the 2 sets of values that I put my lovely shapes around, the markings around. Question on that? Okay. Here's another. So this time, what is the value of j of x? What does it say up there? X to the 4? Okay, so the rule says up there, take the opposite of j of x, so negative x to the 4. Then what is the value of g of x? X squared, good. So then it says plus take 3 times the x squared and bring down the -1. you can make a simple table. Again, I need you to plug in -2, -1, 0, 1, and 2. Plug it in just like you've been plugging in for everything else. Get enough XY points so that you can make your graph, or you can go through it step by step like this chart does. When it says write the new equation, I do that right away. I do that right in my table for myself. Question. So that's using the key and then just doing an insert. So up here for you, I drew this last one, number 5. That is this graph right here so that you could see it finally done. So it ends up with some swiggle to it. It is not a detailed graph, it's a sketch. It had enough that you could have a basic shape, see some of the turns, and that's all I needed. Okay. Does anybody need to see the math that I put in on the chart? No? Okay, good. Okay, watch this one. It's easy, but I can see people mess up. Look at my first graph over here in turquoise, the f of x graph. That is not a parent graph. It's not the x cubed. It definitely has swiggle to it, but it shows me that it's going through, because it wrote the ordered pair, at 0, 1, not at 0, 0. It's counting by increments of 4 on the y-axis. So it's not going through 0, 0. It's going through 0, 1. Are you with me so far? So when I do my new graph, I can't just like put a cube there. I need to talk about my new graph in terms of the old graph, just like we did with those b of x's and c of x's on your last test. Okay, so I chose this point right here, the 0, 1. So not the top one, the next one down. And I matched it up with the other point on the other graph. I need to first see what is happening here. So I wrote myself this lovely note. I started at 0, 1. I went to 1, 4. That's how it shifted. What actions happened to do that? For the 0 to the 1, we went 1 to the right. From the 1 to the 4, we went up 3. Are you still with me? What was the name of this turquoise graph again? It's called f of x. So my answer, g of x, my new graph, took the old graph f and went 1 to the right and up 3. Remember, that's that math symbolism talking about the action that you did. You have to be able to do that all year. Question why I had to put the f there. Anyone? So if you left that off, you will not get full credit, because if you leave that off and you don't have anything there, then you're just really giving me an equation of a line in a not even finished form, which is nothing like those graphs. So be careful. Question. Okay. Last one. This is number 15, right on your skills practice. I need to describe this. So listen to my words. I'm not writing down my description, but you need to write down your description. And then I'm going to write my new equation. So first off, somebody please tell me, what is p of x equal to? X to the 5th. Okay, so we're taking this x to the 5th graph. They can't see me at home doing this, but this is what it looks like. And tell me the 3 actions you see by m of x equals. What does the 0.5 tell you to do? This is your verbal description. What is it? Not divided by 2. Say it. Okay, a vertical compression of half or 0.5. So step 1, vertical compression of 0.5. Everybody there? Now, the negative is inside the parentheses with the x. You had to graph one of these on the last test. Got it. Reflected over the y-axis. That was that parabola that you had to just throw to the other side. Last but not least, what is the 4 doing? Moving it up 4. Okay, shifting it up 4. That would be my verbal description. Okay, I described. Now I need to write my new sentence. Its name is m of x in terms of the p of x. And then I want to convert it over so it's a specific equation. So what power is the P of X equation? 5. So then we need to convert this over to a 5th degree, because that's what it said. It said that one was a 5th degree. So when it says you're using P of, but instead of X, negative X. So I kept it negative, but I changed the exponent. Now that's not cleaned up because I know you know a negative to an odd power is a negative. And where is it proper to put a negative? In the front? Yeah, you don't usually see something and then a negative in the middle and something else. You usually see negative, then a coefficient, and then the rest of the problem. When you put a...
So, for example, on 23, I know we're not doing that.
Let me finish this first, and then you look.
Work with that.
Okay.
Since you have x to the 5th,
Uh-huh.
it's going to flip the 0.5 to negative every time.
Good. Question. Okay, so your homework that's up here is you are doing 2 to 5. You're doing 8, 10, 11, 12, 14 to 16, 20, 23. I'm hoping you get it done so tomorrow we can talk about it so that you don't have homework over the weekend. So that's up to you. Tomorrow, weekly homework question. Tomorrow, anything you need to ask me from your graphing sheet from the beginning of the year that you practiced a couple weeks ago again, so that when you have your graphing quiz on Thursday, you are ready to go. So tomorrow it's up to you to say, Mrs. Stewart, I need you to graph with me again a square root of x. Mrs. Stewart, we need to regraph the x cubed, whatever it is, and domain and range and end behavior, you need to ask about if you're iffy, so you're amazing on Thursday. Okay? Pep assembly tomorrow during lunch, Spirit Day tomorrow. Here's the rest. It was on Eagle Eye, but if you didn't get it, Monday is America Monday. Tuesday is Tacky Tourist Day. That's usually fun. Wednesday is music genre. Freshman is pop. Sophomores are country. Juniors are hip hop and rap. Seniors are rock and roll, so watch out for them. Thursday, you're all wearing your Gator garb. It is Professional and College Sports Day. Friday is Generation Day, and Saturday night is your dance, a week from the Saturday.